So in these notes, we're going to be reviewing triangle trigonometry, which you learned in geometry. So we're going to go through these examples pretty quickly. Once we finish our review of triangle trigonometry, then in the next lesson, we're going to apply what we learned to the unit circle, which we've been working in degrees and radians on. Okay, so on the front, just a reminder, SOHCAHTOA, that's the acronym for sine, cosine, and tangent. Recall that sine is the ratio of the opposite over the hypotenuse. The hypotenuse is the longest side in a right triangle. It's always opposite the right angle. So the sine of the angle theta, which is in this corner over here, would be the ratio of the length of the side opposite over the length of the hypotenuse. Then the cosine is the ratio of adjacent over hypotenuse. So back to our angle theta, the length of the adjacent side is the one that's attached to the angle, and then the hypotenuse again is the one that is opposite the right angle. Then TOA stands for tangent, is the ratio of the opposite over adjacent. So our angle theta, the opposite side is across from theta, and the adjacent side is attached to the angle theta, but is not the hypotenuse. Remember, the hypotenuse is opposite the right angle. So to find an angle, to find a side, when you're given an angle and a side, you would use sine, cosine, or tangent. Then the inverses of those functions, the notation here, recall from Unit 1, that little -1 there means inverse. So the sine inverse of opposite over hypotenuse, that would find the measure of the angle if you were given those two sides. Another way you can say sine inverse in trigonometry is arcsine. So the arcsine is the inverse of the sine. Arccosine is the inverse of cosine. Arctangent is the inverse of tangent. So let's go ahead and look at example 1. And we're asked to find the exact value of the sine of theta, the cosine of theta, and the tangent of theta. So when we look at the illustration of our triangle, here's our angle theta. The 5 is opposite of that angle, and the 2 square root of 7 is opposite the right angle, so that would be the hypotenuse. Okay, and SOHCAHTOA is our acronym for the trig ratios. And sine is the opposite over the hypotenuse, and we know the opposite and the hypotenuse. So the sine of angle theta is the ratio 5 over square root of 7. Now, recall from Algebra 2 that we can't leave a square root in the denominator of a fraction. It's not considered simplified until we rationalize that denominator. So to get the square root of 7 out of the denominator, we're going to multiply the numerator and denominator by that radical. So now in our numerator, we have 5 square root of 7, and in the denominator, 2 square root of 7 times square root of 7 is 2 times 7, which is 14. So the sine of theta is equal to 5 square root of 7 over 14. Now to find the cosine, cosine is the adjacent over the hypotenuse, and we don't yet know the length of the adjacent side. So to find that, we're going to need the Pythagorean Theorem, a squared plus b squared equals c squared, where c is the hypotenuse of the right triangle. So we'll have a 5 squared plus b squared is equal to the quantity 2 square root of 7 squared. 5 squared is 25. And 2 squared is 4. And then that's times the square root of 7 squared, which is 7. Okay, so when we go to get b by itself, we're going to have to square root both sides. And 4 times 7 is 28. And we subtract the 25 from the other side. And so the length of side B is exactly equal to the square root of 3. So the cosine, since that's our adjacent side over the hypotenuse, the cosine is the square root of 3 divided by 2 square root of 7. And again, we'll need to rationalize that denominator by multiplying by the square root of 7 over the square root of 7. The square root of 3 times the square root of 7 is the square root of 21. And then 2 times 7 is 14. So the cosine of theta is equal to the square root of 21 over 14. Okay, then the tangent of theta, that's TOA. Tangent is the ratio of the opposite over the adjacent. Our opposite side is 5, and the adjacent side is square root of 3. So 5 over square root of 3, and we're going to rationalize that denominator by multiplying by the square root of 3 over the square root of 3, and that reduces to 5 square root of 3 divided by 3. And that would be the tangent of theta. Okay, so go ahead and pause the video. Try these two problems on your own. You want to find the exact value of the trig ratio cosine of theta, and then the exact value of the sine of theta for these two problems. When you've worked them out, go ahead and resume the video. Okay, so welcome back. In example A, to find the cosine of theta, first we would do the Pythagorean theorem to find the length of the hypotenuse, which is c, because cosine is the ratio of the adjacent over the hypotenuse. Okay, when we get to the square root of 208, remember to reduce that radical. You learned how to do that in Algebra 1 and Algebra 2. So 208 is 2 times 104. 104 is 2 times 52. 52 is 2 times 26. 26 is 2 times 13. So we have two pairs of 2's. That's the 4 out front. And then the 13 stays under the radical since that doesn't break down further. So the square root of 208 is equal to 4 root 13. When we take the square root of both sides, we get a plus or minus answer, but because this is a triangle, in this context, it wouldn't make sense to have a negative hypotenuse. So we keep the positive value 4 root 13 for the hypotenuse. Then our adjacent side is 8, so the cosine is 8 over 4 root 13. Then we need to simplify and rationalize the denominator, and we're left with 2 root 13 over 13. Okay, then in example B, to find the sine of theta, again, we're going to need to use the Pythagorean theorem. This time we ended up with a Pythagorean triple, 5, 12, 13. Pythagorean triple is 3 integers that work in the Pythagorean theorem. And then the sine is the ratio of the opposite over hypotenuse, so that would be 12 over 13.